Alan, this is Naveen here.
Hey, thanks for joining.
Yep. Thanks for this call. Thanks a lot.
Okay. Absolutely. So, I'm sharing. Can you see my screen? Did you get to jump into the WebEx?
Yep.
So, on that email you sent me, just to give a little context around the meeting, we're here to discuss the POC in general. And just so everybody knows, I have Michael Rainey on the line, by the way. He's our senior. Yeah, he's been on. He's been on with us the whole way. He's going to be our engineer, helping us out on the POC. And I, in the background, tries going to help us out in case there's something we don't understand or we don't know from the, I guess, infrastructure side. So, yeah, you guys are ready to talk about the POC. So, do you want to tell us some of your concerns before I ask any more questions?
Yes. Yep. So in terms of providing a high-level background, so like some of the use cases that we have been talking about, now we have an ND in place, so probably can dive a little bit deeper into the specifics of the architecture that we're trying to lay out.
Great.
So Lowe has an application called centralized pricing and inventory. We call it as CPI. So it's a centralized application that provides pricing as well as the availability information for customers who either shop online or in cases to the store employees who are not able to find the item at a location and they have to find out if the item is available at a nearby location to check the availability. So the store employees by themselves, they carry a mobile app so that behind the scenes actually interface with this application. Have all of our digital channels, so .com, our mobile app, so we Apple Watch, so all of those actually interfaces with this centralized application for, like I said, getting price as well as the availability, and it's all real time. So information gets application from all the locations. So scenario wherein we have like 1,700 plus stores. They are all selling actively at the same time. Now, as soon as inventory is updated at any of our store locations or our distribution centers, they trigger a real-time update to notify the enterprise of that inventory change. Is one of the applications that receives that update, the update inventory, and at the same time, the digital consumers like .com, our mobile app, they are getting real-time web service call to the application to get the current availability as well as the price.
Got it.
Okay? Does that make sense?
It sounds like you basically have a centralized single source of truth, which is accessible by all web applications, whether it's through mobile, the .com, Apple. Everybody basically goes through this hub and to find out the source of truth in terms of global inventory and availability across stores, 1,700 stores. Yep. Right.
So stores actually, they have their local inventory, but they do update the application anytime if there is an inventory change.
Right.
If you think about that scenario, so this update which is happening to this centralized application, right now this application is built on top of DB2. It's a VAS server running on mainframe. And web service calls that we make behind the scenes. So it's all XML over HTTP. And then you could assume the scalability as well as the performance concerns that we have with this application in current state.
I think you're going to see, in terms of read performance or the read intensive transactions, you're going to see a lot of MIPS offload as well. So we might have, depending on how you want to organize the architecture, you could see a lot of savings as well.
Right, certainly. So we are hoping that as well. So that's kind of at a high level. This is what the architecture is in current state. So current state, what we are trying to do is to actually leave everything from a consumer and a provider standpoint pretty much the same. Okay. But instead of having the CPN application, DB2 database, and then result in real time, we are trying to actually introduce caching layer will then be able to provide fast access to this data. Not only solve the performance concern that we have, help solve the scalability concern that we currently see in our architecture. Mainframe or DB2 on mainframe, we currently have a limitation wherein we cannot replicate the data across our data centers.
Mm-hmm.
We only have the option of running hot cold, right? And there is a need from the enterprise to actually enable more of hot deployment architectures.
Excellent.
Currently see our CPN application as limited to that architecture at all. I mean, in its true sense. So that's another aspect that we're trying to bridge. Obviously, like you were saying, cost is another factor that we're looking at in terms of freeing up some of the capacity on the mainframe servers itself, and be able to provision these services on the integration middleware platform. Data access will be through this cache layer. The service will solely reside upon the integration platform itself. And then there are a lot of business rules that we see that are hard-coded within the CPN application in current state. So we want to move them to a centralized business rule engine. So the business user as well as the IT users, they centralized view and also provides them with a self-service capability to be at all of those different rules around pricing as well as inventory. So that year we had our interest on understanding the BRE capability that you have to offer. Remember the conversation that we had around rules?
Yeah.
The interest that we had in terms of finding a centralized home for all the business rules that we currently have in current state.
Excellent. How do you guys do the rules today, may I ask? Is it some sort of procedures running on mainframe, or?
Yeah, pretty much. So every application has got their business rules embedded and hard-coded within their application layer. So at enterprise level, we don't really have a BRE solution. There's no self-service capability. There is not a single place wherein business users by themselves can go and modify those business rules or even get a view into the business rules.
Yeah, I came from that world, so I can really speak to this. Is it COBOL store procedures, or are you guys using native SQL?
That I won't be able to tell. That's for somebody. I represent the integration side of things.
Okay, no problem.
But the application people would be able to. I have a feeling that they are all they are everywhere. So they are in COBOL, they are there in Java code.
Yeah, maybe.
Yeah.
Yep. Okay, great. This is exciting because this seems to every single point you hit seems to be something we're already doing with existing customers. So
Right.
This is excellent.
Yep.
Is there a scenario you can give us that kind of represents the rules that are executed against inventory or pricing?
Lots of them actually. So one being, so for those, so every time when you shop online, if you have ever shopped at Lowe's.com or using our mobile app, so price is actually a function of the location that you're shopping in. So if you're zipped into a location, let's say somewhere in Northeast, the price that you may get for the same item may not exactly be the same as the price of that item in West Coast. They may vary depending upon what the dynamics is. So if you zip into a location, you see an item, and then availability for that item is based upon that location that you're shopping in. Certain rules on the basis of which we determine the availability. One being the location that you're shopping in. This notion of a yes or a nearby facilities we call it, right? So it's not available physically at the location that you're lived in. Be sourced from the nearby location. Then have this concept of a radius, and really varies based on the location that you're zipped in. Meaning you're zipped into a location in Nebraska, we have a radius of 200 miles to pull in all these stores within that radius, and then the inventory for all of those locations. If you zipped into a more densely populated location like somewhere northeast, like New York, etc., they actually have a driving mileage or a distance or a radius of some 50 miles. Some locations it is 75 miles. So that's the rule, right? Other could be when you're looking for the availability, we not look at just the physical inventory, the on-hand inventory. We also look at the inventory which is on order. Look at the inventory which is going to be at the full locations. Fulfilling locations, these are all distribution centers that are constantly replenishing our stores. So for a washer and dryer, let's say a New York location, is not available at that point in time at that location, we have to see if it is available at a distribution center. If it's not there at the distribution center, then we have this notion of coastal holding facility. Then check there. If it's there, then we go and check if it is on order. If it is not on order, then we have this other locations that we look at to be able to provide you an answer. Hey, you know what? We can't fulfill it today, but we have 5 of them coming in 3 days from now. Do you still want to place an order? You will be able to pick up, or you will be able to get the item delivered to you 3 days from now. So all these, what I just described, all of these are rules that are stacked one over the other in terms of how the code has to traverse through all the locations before respond back to a consumer call. Does it?
Yes, yeah, it does. Seems to be a lot of complex rules there. Yeah, absolutely.
So just on pricing alone, we have about 200 plus rules, business rules, in terms of how we decide the price for an item. So there are permutation and combination. So if the item is always stocked, we offer one price. If the item is always stocked but it's not available right now, you get a certain price. It's coming from a vendor, and there's a different price for it.
Sure.
So there are permutation combination in terms of how we arrive at a price and the availability. So there are rules for both actually.
Naveen, where these rules are executed, where they're running right now, on the mainframe?
You are within that vast application that I described earlier. So the application has actually all of these rules kind of hard-coded within the application.
This OS is running on some commodity hardware or on the mainframe?
Mainframe. It is mainframe, yes.
Right. Okay, so it's on the mainframe. Oh, I see. Okay.
All right.
So the goal that we have in the target state is to actually get rid of the complete CPN application off of mainframe. We may still leave the database by itself, the DB2, serve as the operational data store on mainframe, but we want to get off the CPN application off of the mainframe environment completely.
Excellent. Okay, great.
So, question, these are all great thoughts actually. So keep them rolling. If you have any more, I'm more than happy to answer them.
Well, I think, and Mike will get into it in terms of details, we have, as part of XAP 11, a new geospatial capability. And that's extremely interesting, specifically when you said, you know, something's 50 miles away. What are the particular stores that are available for me to kind of, to add in terms of, to understand which has the inventory available. But after you to explain yourself, explain the use case, it seems like it's not the only rule that's in play here. So it kind of drops back to the original kind of Jules idea or having some other terms of logic. If you want to do this in Java, I think you might be really excited about what we have in terms of our geospatial API with XAP 11. That just went GA a couple days ago or last week. So I think that might be worth your time in terms of maybe a demonstration from Michael's side eventually, and we'll talk about whether or not it is enough for you to make those rules, or we want to continue with the rules. But I think the way you're going to be satisfied with what we have.
That sounds good. That sounds awesome actually.
Cool.
Since we have only got 10 more minutes, so I want to actually deep dive a little bit into the POC. So that we have now from our leadership is to actually evaluate a cache solution. So Lowe does not have a caching solution in its current state. So we're looking for an enterprise class caching solution, primarily either a in-memory data grid. Then people are also advocating to look at a NoSQL database. So we are going and evaluating both right now. So you definitely fall within the in-memory data grid space, which is
Sure.
a track that I'm leading. And if you remember, he was the other EA who was working on evaluation on the SQL databases.
Mm-hmm.
So we are working pretty much.
Hello? I hear you.
Hello?
I hear you now.
Okay, perfect. So
Okay, okay. Sorry. Go ahead.
Yeah.
That from a PC standpoint, we are looking at it from multiple perspectives. So we got this in-memory data grid, and we've also got the NoSQL databases that we're evaluating right now. And the goal really is to see which solution provides us the right performance as per the SLAs we have with the business cost point. And we are after really identifying the solution based upon these two key parameters, right? Obviously, we are looking at a lot of functional capabilities in terms of how do you handle DR, how do you enable an active-active architecture for us across data centers, and how do we get from the solution. And our goal is to provide the scalability and the performance to the enterprise, right? So CNI is just one use case that we have identified. A lot of other use cases. So customer data is another. We got a lot of customer lookups across all the store locations, plus online, and plus all the other allied businesses that we have today. So, customer MDM is another evolving area wherein we do see a potential of linking the caching solution. Also looking at employee, right? Employee data is being frequently accessed in multiple domains, so that's potentially another area wherein we can support the first apply or the web services pattern using the cache. And then we have some miscellaneous, data categories, right, which we see as geospatial information, right? When we currently leverage Google Maps, and we have a solution called ASRI, which is what Lowe uses today to find the driving distance from a customer location. If I have to go deliver a washer and dryer to a customer address, then to actually get some optimization on the delivery route, if we do 4 deliveries within a same area, so we use a certain software to actually determine the best path. So those decisions based upon the driving distance.
What was that software name called?
It's called ESRI.
As yeah.
Yeah.
Yep.
It provides a geospatial information based upon lat and long. So that's another use case wherein I see cache being used because that information is not going to change very frequently.
Mm-hmm.
That's a good use case for us to leverage. And then we do see a lot of other use cases in terms of the enterprise looking for data for a product, of the 360-degree view, like the kind of video files for all the product data. So with all the due diligence to find out other use cases wherein the caching solution might fit in. But the point is, so based upon all of these different needs, so we came up with some sort of a capability map, is what we call as the in-memory FR for Lowe. Based upon that, we have a certain evaluation criteria in terms of the core capabilities that we are looking at from the caching solution. So the POC is really set out to load data in a cache. Then we are actually working on a smaller subset of the environment as we do production. So I'm thinking of using 1/3 of the data that we actually see getting loaded and used, specifically for a CPNI use case. We did some math, so we found out that we have got about 7 million records in the DB2 database, which have to be loaded up in memory. So we took a column count, and then we looked at all the data, we dumped all of that into a file, and we played with some numbers, and we found out that it's going to be somewhere around 125 to 200 gig. is the data size for production data. You see, I'm looking at about 1/3 of this data. Obviously, I cannot stand up an environment with, that can hold and support all of the production data for a subset. And then obviously, based upon the learnings from the PC environment, we have to extrapolate it and then make recommendation to the enterprise. Take 1/3 of 150, right, or 125. I'm looking at roughly about 50 gig of data to be loaded in memory, about 50 to 60 gig of data, right?
That's raw data, right? Raw data from the database.
Right, and obviously it will be converted to a canonical format.
Right.
We have to still go through some sort of data modeling, right? Some sort of a design for how the data will be expressed in memory. Add some factor in as we came up with that formula. So it's not a plain count of number of rows and columns and the number of bytes that are currently stored. We introduced a formula in terms of factoring in how much space it will take in memory. So there is this, we use some math there. But so if the requirement for the POC is to store some close to 50 to 60 gig of data, so in our previous conversations, I worked with my engineering team as well. What they promised us to give is a node, a VMware node, with 24 gig of memory, which will have 50 gig of flash storage, have 4 cores. Dedicated, I'm asking them to give me dedicated cores. Still looking to get the approvals and everything. It's not a norm. Hoping that they will be able to give us 4 cores at least. And for 3 of these nodes, for us to be able to evaluate your solution. So the question I have is good enough for us to be able to understand your solution? And like I was saying, only 1/3 of the data, looking at gauging the performance for both the reads as well as the writes, and we make sure that we do some sort of fault tolerance test as well as high availability test in terms of bringing the nodes down. You can still live with just one node, to get the data replicated across multiple nodes and things like that. So tell me, I will not answer it right now, but if you can respond by an email, is that a good configuration, or do I need more nodes?
No, I have the right guys on the call. So basically, you have 50 gigs of raw data. So it depends what types of actual attributes are. If it's a string, it might be more. If it's an integer, it might be a little less. If it's bytes, it's almost nothing. So it's really hard to say 50 gigs will translate into 60. It comes into a canonical format. So let's assume 60 to 65, right?
So just assume that when I say 60 gig, it is the canonical format.
Okay, so 50 we're talking about, okay. So now we're talking about the canonical format.
Somewhere around that, actually.
Okay. If we take 50 as a premise, you're providing us with 3 virtual machines that have 24 each, right? That's 72 gigs total. Now, if it didn't have backups, take that, because it's 50 out of 72, giving us about 20 gigs of overhead, assuming there's decent concurrency. I think can operate in that kind of setting. But if you want to do any kind of fault tolerance, we'll need at least a single level of backups. So by multiplying by 2, we get to 100 gigs, and we have 72 available. So naturally, we can't do that. If we were to do fault testing, we require at least 100 gigs, or to take a slice of that 50 gig in order to actually have a space to do any kind of fault tolerance on 2 gigs worth of machines. Does that make sense?
Okay. Yep. Okay. So the data will still be partitioned. So you're saying that we will still have all unique data on each node, right? So you don't have a room to actually mirror that data.
The backup is a full copy of the primary. So in other words, we have 50 gigs partition across the entire cluster, the backups, you would need the amount of space in order to have full high availability.
Yep, understood. So you suggest if we have to check or test for high, would you be going with 6 nodes instead of 3?
Yeah, I think. Let me see. 6 would be what, 72 times 2 essentially, 140. Yeah, I think we'd be fine. Absolutely. Or if it's a let's say if it's less work for your infrastructure guys, we can reduce that 50 in half and make it 25 as well.
Again, if we reduce it to,
let's, for example, if you don't want to have the infrastructure guys make double the amount of VMs, you can just reduce the 50 gigs to 25, and then it become 50 once we have high availability, and we still have overhead to work with.
okay.
It could be just less work on your infrastructure guys, and we could reuse the same environment. Just a suggestion.
Oh, sounds good. I'll actually work with them to see what they can do. A POC by itself has got a fixed cost to it.
Mm-hmm.
So there are not, funds for us to play with, given to set up this environment for each vendor. So one of that I'm still, vetting through internally is probably repurpose. So this primary for each vendor. Probably can use the primary for one vendor as a secondary for somebody. You see what I'm saying? Is if I'm going to have 3 of VM for gigaspaces,
Mm-hmm.
and let's 3 for terracotta, right?
Okay.
We will keep your 3 VMs as the primary for gigaspaces. 3 primary for terracotta will become secondary for gigaspaces.
Oh, in terms of reusing it when we need fault tolerance?
Yeah, because at a given point in time, we'll only be doing the execution with one solution at a time.
Yeah, makes sense.
We will not be running both, let's say, gigaspaces and terracotta at the same time. And then we could do the same for terracotta too. So use your nodes as secondary, the gigaspaces nodes as secondary, and then terracotta being the primary and things like that. So I think that I'll talk to engineering if cost becomes a concern.
Mm-hmm.
That's something that we can work with. But at high level, do you have any major concerns with this configuration, or does that sound okay to you?
No, it's 4 cores, we have about an 8-to-1 ratio of gigabyte to cores. I think that's going to be okay. It really, the level of concurrency that you want to work with, 4 is not a lot. We try to have at least 8 on production boxes, but it really depends on your concurrency. So do you know what kind of success criteria you have into write intensive or whatever kind of transactions you're going to be running against the data?
Right. So our transaction volume overall, when we did the test actually, so it's like 5,000 TS.
Whoa.
Actually both reads as well as writes. But however, sorry, I have to run for a meeting, I'm getting pinged.
Yeah.
The read and write ratio is almost like 60-40.
Okay. At the peak, it'll be 5,000 TPS across all 3 machines, yes?
Yeah, across all 3 machines, yes.
Okay. All right.
And
yep.
it's 40 read writes.
Okay. I don't think it'll be a problem for us in terms of read writes. We'll handle both. All right. So let you go to your meeting. I don't want you to get held up. I'll take that the TPS discussion with Shai and Mike, and I'll write you an email to follow up. Sounds good?
Oh, that sounds awesome. I'm sorry about cutting short this discussion.
No,
but catch up again, and like I said, Alan, so I'm still looking to actually schedule probably an on-site event with us. Have you meet our directors, so Suraj Malhotra, who was part of some of these conversations, is now taken up our director's position, our integration. So he's moved over from the EA over to the solutions team. So I'll actually have you meet him, and then you will get a chance to actually meet some other folks within the team. And then we can go over the detailed architecture diagrams and things like that, and then have a deep conversation on what we are trying to solve for.
Excellent.
Hey, hey Naveen, this is Mike. Is it a chance you can get maybe some of the schemas that you currently have in your database, get it over to us so we could take a look and have a little view of the modeling?
Yeah, absolutely. Absolutely, yeah. I'll do that. That's a good idea. Yeah.
We'll follow up some stuff.
Yeah.
Thank you. Thank you for your time.
Yeah, thanks a lot. Thank you, everyone. Thanks so much.
Thank you.
Guys.